Okay, let's make a video for homework 8. And let's start from, that's a bean, and we'll make a bean in the CAD first, so we don't have to insert 31 nodes. And this is inch model, and I'll save to a new place. Okay. Homework 8. Okay, so basically you just need a 30-inch edge. Okay, so we'll insert design feature, insert a block. You can also do extrude. Insert a block, and this Y direction, X direction. So on the X direction will be 30-inch. Y and Z doesn't matter. So that's the edge we need. And this is done, then we can switch to advanced simulation. Next step, we'll right-click on the part and build a fan and a sim. Okay, and everything default. And now the second window, we need to be careful. Here we need to do a solver 103 real eigenvalue. Yep, this one. Okay, then we'll say okay. So now this time it's a dynamic problem, so we'll use a different solver, right? And in this new window, you don't have to change anything, just say okay. Alright, and you notice we don't have load here because this solver 103 eigenvalue. And we're in the simulation. We need to go to the FEM first. So we can go to FEM and we'll do a mesh, insert, element, create a 1D mesh, C bar or C beam. I guess it's C beam. So top C beam, and ease the edge. So we'll just well, not this. We'll do 1D from here. Yeah, 1D mesh. This one will actually allow you to select an edge. Then C being the mesh size, we can say mesh number. I want a 30 element along the edge. Then we're done with the polygon. Just turn it off. Then we have this 1D C beam. You can turn on model display and turn on the marker to asterisk. Then you try to select them. 62 objects, that means 31 nodes, and 30 elements. There's one more stuff there. So we can try element, just make sure we have 30. So 30 elements. Okay, then next is the cross section and the material. So first, let's define the four section. Build a new one. Type is a bar. Then dimension 1. So on Y direction is dimension 2. That'll be 3-inch. Dimension 1 is on Z direction. It's 2-inch. Okay. Close. Material. So here material is a little bit tricky. You can pick steel rod and copy this because this is a new material, right? So we need to define. It says use steel. I guess you can use steel. Anyway, I'm going to show you the whole thing. Change the Young's modulus. So we're going to override the Young's modulus to PSI and 30 to the 6. Yeah, 6. Poisson's ratio. Make sure you click override 0.28. Alright, then the tricky thing here is the density. So if you use this way, rho equals 0.3 divided by g, gravity, that pound here is pound force. Okay, so that'd be equivalent to this pound force times the pound force divided by inch cubic, then divided by g will give you a second square and divided by another inch. So it should be like a 0.3 divided by gravity here is 387.4. However, we have a faster way. So from pound force divided by gravity, it actually gives you pound mass. So you can simply type in 0.3 pound mass per inch square, per square inch, per cubic inch. So you can simply use this, okay, pound mass. Yes. Okay. Then say okay. Then that's the mass. Okay. 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 All right. So that is you have to make sure your 3-inch, the long edge is along the y direction. So take a look at this y direction. Then we go back to the sim, and we need to constrain some of the nodes. So constrain QDOF. Get rid of this. Well, that is crazy. Okay. QDOF 1, 3, 4, 5 from on the middle nodes. And the nodes are between. So we'll user define. We select the each side, the end first. Kill 1, 2, 3, 4, 5. Right? So we just fix everything first, then free 6. That means this can go rotate on the z direction. Rotate on z direction. Yeah, because we are looking at the vibration on the y direction. So you want this beam to rotate along z. This will go make this go up and down. And apply. That'll kill the degree of freedom for the node 1 and 31. Then we pick the nodes in the middle or in between. Kill everything first. Then free 2 and 6. 2 is a y, right? So this one can go up and down, and this also can rotate on the z direction. So this node will go up and down, and also rotate along the origin, or actually rotate on any, as long as it's on z direction. So free 2 and 6, okay. And setup is good. Then you can do a model setup check. Just make sure everything's good. Then do a solve. And okay. So I'm not sure if this will write into your F06, but we'll see. Job finished. Close, cancel the results, and that's the correct results. And in terms of the dynamic, the error will gradually get bigger as the mode gets larger. So the first one might be 1% off. Mode 10 might be 40% off. Because I guess that's the nature of your front-end element. So that's the second mode shape. Third mode shape. Just show a screenshot of 1, 2, 3 mode shape. Then also compare those frequencies to the handle calculation. So let's take a look at the frequency, which is desktop homework 8, F06. Results in the F06. Okay, it's not at the bottom. You need to go up a little bit. Here, the real eigenvalues. That's all your the modal frequencies. That's the mode 1, 2, 3 to 10. Oh, you have this cycle is the frequency, right? Cycle, that's omega. This lambda. So you can use the Excel. But if you just copy this into Excel, it will not work. I don't think Excel will separate them into slots. Oh, oops. Okay, copy, paste, and that is one big thing here. Don't know if we. Oh, okay. So when you paste, after you paste, you can open this paste option, use text import wizard, then we use fixed width. Okay, this is not separated yet. So use fixed, oh no, use the first one, delimited. So there's a comma or some space to separate them. Then you just check space. It'll automatically separate them into columns and just finish. So this way you got cycles, that's your cycle. That's all you need really. Then you can add a column of hand calculation and compare and get error percentage. So that is all for homework 8.